So that leads us to, let's see, I mean, so what exactly is happening during this cold start time for, especially for the large models, right? Right. I mean, why does it take so long for a model to load into the GPU? Can you please explain like what's going on during this time?
Yes, yes. For the inference with a large model, actually the cold start latency include two major part. The first part is easy to understand. That's the model loading. You know that's for the model-based inference, that model size could be for the small model it is a few GB, and for the large model maybe it's 100 GB data. In order to serve before the model can serve the request, all the model data need to load it from the source to the GPU memory. Depends on the source bandwidth. For example, if the source is in the remote store S3, the bandwidth is a few hundred megabytes per second. Even that in the local disk, that is a few GB per second. It will take maybe a few seconds and to the 10 minutes to load the data. To load data to the GPU memory. Yeah, this is the first part for the latency. And the second part is from the framework initialization. For example, when we use VRM for the inference, when VRM first start, its initialization will need to be done. It's include, for example, initialize graph, or do the create the CUDA object like the stream, like CUDA Blast, this kind of object. Maybe sometimes they also need to do compilation for the CUDA kernel. It will take tens of seconds. Here, add them together. This first is model loading, another is framework initialization. It will take tens of seconds to do the normal cold start. Yeah. And because this two process is totally different than the CPU-based workload and much heavier than the CPU workload. So traditional that's the CPU-based optimization is hard to cannot be used in this area and cannot decrease cursor latency for GPU application.